Good morning, good afternoon, or good evening, depending on when you are watching this maths video. We're starting a new topic today, and it's quite a difficult one. It's one that features a lot in Nat 5 exams, so an important one. And we're starting with surds. Now, I've listed on the board the first 11 square whole numbers. 0 squared is 0 times 0. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. So the third perfect square is 4. So what we have listed there are the squares of the first 11 whole numbers. You'll need to remember them. Now we know that squaring a number is the number times itself. So 3 squared is equal to 3 times 3, which is 9. Square root undoes squaring, it's the opposite process. So the square root of 9 is equal to 3. Root 9 equals 3. Since 9 is a perfect square, the square root of 9 equals 3, and it is not a surd. 7, for example, is not a perfect square, so root 7 is a surd. Now in this work, do not use a calculator to find an approximate answer for surds like root 7. We will simply leave it as root 7. So root 2 is a surd, root 3 is a surd, root 5 is a surd. These are not perfect squares. Root 8 is a surd, root 12, root 37, and many more are surds. Now some surds, like root 3, cannot be simplified. But note this, root 36, that's not a surd. Square root of 36 is equal to 6. But we could write root 36 as the product of the square root of 4 times 9. So root 4 times root 9. We know that the square root of 4 is 2 and the square root of 9 is 3. So that's 2 times 3 is equal to 6. So root 36 is equal to root 4 times 9 equals root 4 times root 9. So we can write it like that. Let's do some examples then. Now you are often asked to simplify surds. So if you are asked to simplify root 12, you would have to ask yourself, can you think of two numbers that multiply to give 12, one of which is a perfect square? And they're on the board there, root 4 times root 3. And I've written root 4 first because that's the perfect square. So root 4 we know is 2, root 3 is root 3. So I can simplify root 12 and write it as 2 root 3. Doing the same with root 48, if you were asked to simplify that surd, you would be thinking, are there two numbers that multiply together to give 48, one of which is a perfect square? And when the numbers get bigger like this, that's when it's helpful to have the perfect squares along the top of your jotter. So square root of 48, 16 times 3 is 48. So we would write square root of 48 is equal to root 16 times root 3. Again, I've written 16 first because that's the perfect square. So root 16 is 4. 4 times root 3 is 4 root 3. Now let's try that again. If you had thought, well, two numbers that multiply to give me 48, one of which is a perfect square, I'm going to write 4 and 12, and that's absolutely fine. So that would simplify to 2 times root 12, but you are not finished there. You have to keep checking that the number under the square root sign cannot be simplified any further. And this one can. We can think of two numbers that multiply to give 12, one of which is a perfect square. That's what we did in the previous example. So that's all right as long as you realise you're not finished there. We would write root 12 as root 4 times root 3. So that would give us 2 times 2 times root 3 is 4 root 3. So it doesn't matter whether you write root 16 times root 3 or root 4 times root 12, as long as you then simplify the root 12. There's only one correct answer, 4 root 3. Root 125, can you think of two numbers that multiply together to give 125, one of which is a perfect square? Well, again, if you have the perfect squares along the top, root 25 times root 5. Root 25 is 5. 5 times root 5 is 5 root 5. And that's what you're going to be asked. You're going to do 2 exercises today, and the second exercise you're going to be asked to simplify surds in exactly the same way. Okay, keep working hard.